Hey guys, in this video we are going to be doing something very similar we've done in the last few. We are almost done with this section of trig functions, triangles, all that jazz, but we do have a little bit more to do. This one should end up being very similar to what we did in the last video, where you had to find the missing length of a triangle, or the missing side, and then find the trig ratio that corresponded with it. So this is very similar. So if you remember how to do that, again, very similar. This one, the problem looks a little bit different, but I promise it's not any more challenging. So in this one, it says we've got theta as an angle in standard position. So what I want you to think about is unit circle, right? And it says theta is some angle in standard position, and its terminal side passes through the point 724. So what I want you to just think about is this is an x value, and this is a y value, 724. So if you were to go out here, let's say this is 7, and then up here is 24. Basically, you got a point here, and this line is going through that point 7, 24, right? And then theta is this angle here. Angle that's formed by that. So what you've got is essentially a triangle here. And this triangle has a length of 7 here. And this side, since this here represents the height, corresponds over here. So that's 24. So essentially what you don't have of this triangle is the C. And that's going to be the same on all of these. Basically what you want to think about is, given this coordinate pair, those are just the sides of the triangle. You got a 7 side and a 24 side. And you got to find the C. After that, we're going to find the exact value of cosine of theta in the simplest radical form. So let's go ahead and find that C. So we're just going to use the Pythagorean theorem, a squared plus b squared equals c squared. So we've got 7 squared plus 24 squared equals c squared. Just go ahead and do that computation on your calculator real quick. 7 squared plus 24 squared gives us 625 equals c squared. So then take the square root, and c is 25. Boom. All right, so that's good. So now with this triangle, we've got 3 sides. So let's just then think about, well, we're asked to find the cosine. Might want to write out SOHCAHTOA. I know I always do. It helps me to see it visually. Cosine is the adjacent over hypotenuse, right? So adjacent is going to be 7. Hypotenuse is 25. So all we got to do is type in 7 over 25. And boom. In some ways, I think this can be easier than actually what we've done. You can see the explanation there. Did the same thing, plot it, draw the triangle, label them, find the third side, and then just use the cosine angle there. All right, now let me get to a little bit harder one. Okay, so you'll see in this one, same exact thing, except we got a negative coordinate here. So what I would suggest is still always just draw the little axes here. And if you were to plot this point 8, -7, think about what quadrant it is in. So 8 is going to be out here in the x direction. -7 is down here. So when you plot this, it's going to be down in the 4th quadrant. Okay, the 4th quadrant. So essentially what we have is a triangle still, right? And this triangle has a side of 8 and a side of 7. 8 would be this side. It doesn't even matter which side you label them. You just know your legs are 8 and 7. Never mind the fact that this is negative. It just tells us what quadrant it's going to be. Since the x is positive, y is negative, that tells us we're going to be in the 4th quadrant. Quadrant 4. All right, so you might still also want to have your unit circle out. You still might be useful in this in determining the signs. But we still just want to find the c here. So we got 8 squared plus 7 squared equals c squared. 64 plus 49 equals c squared. That's going to be 113 equals c squared. Fortunately, that is not a perfect square in this one. radical 113. All right, so then let's think about, well, two things. First of all, cosecant is going to be our angle, so we need to think about what that ratio is. If you need to just write out SOHCAHTOA, again, do that. And again, hopefully you have your unit circle there right with you. And you might even remember cosecant is the opposite of sine, right? So if sine is opposite over hypotenuse, cosecant is going to be hypotenuse over opposite. So hopefully you got that stuff down, or at least your little chart on your unit circle there. By now, hopefully you've written that down. So you got that to reference. So it's going to be the hypotenuse over the opposite. So in this case, the cosecant of theta, the hypotenuse of this triangle we just found was a radical 113. And opposite of the angle is going to be 7. So I guess it does matter what place that you put these in. Sorry, I shouldn't have said that earlier. The 8 does need to be up here and the 7 here because the angle is going to be there. So this is our triangle 8 and 7. So it doesn't matter which part you put those on. It doesn't matter when you calculate the Pythagorean theorem, but it is meaningful when you do these ratios. So there's our ratio, radical 113 over 7. We do need it in simplest radical form, so verify that. This is simplest radical form because there's no perfect squares in radical 113. The last thing you have to consider as you're typing this in, square root of 113 over 7, is the sign. Because we are in the fourth quadrant, right? So we need to think about, is cosecant, is that going to be positive or negative in this quadrant? All right, well, let's consider, first of all, cosecant was the opposite of sine, right? Cosecant goes with sine. It's flipped. So whatever sine is, that's what cosecant is going to be. Again, if you have your unit circle, you can probably just look at and see the quadrants, because I made a little list on the last video where we had like quadrant 1. They're all positive, right? Quadrant 2, the positive ones in quadrant 2 are the positive y's, which are at sine and cosecant, and then all others are negative, right? And then in the fourth quadrant, the positive ones that we had would be tangent and cotan, right? And then all others are negative. And then the fourth quadrant, the positives, and that one would have been the positive x's, so that's going to be the cosine and secant. And then negative are all others. So hopefully you have that little chart. If you don't, you can just think about sine. Sine is the y coordinate. Y would be negative, right? Sine is negative in quadrant 4, which means cosecant would also be negative. So we need to throw a negative symbol on there to complete the deal. This really puts together everything we've been learning over the last, I don't know, week, 2 weeks, because you got to think about all this stuff. But again, if you got your unit circle there, take it step by step and you can get through it. That's another positive. So there we go. Here's a negative and a negative. So first thing I would do, again, is draw just a little coordinate pair, -7 in the x. So it'll be like -7 here. And it doesn't have to be to scale, -24 down here. So that's where your point would be. All right. And then so your triangle is going to look like this. We got our theta here. We've got 7 on this side is the length, and then 24 on this side. So that the opposite side is 24, the adjacent side is 7. Make sure you're drawing the triangle the right way on this one as well. When we say standard position, that means the angle should be performed with this side here and the x-axis. Do not put the angle over here. That would be wrong because then the angle isn't formed with the x-axis. So just make sure that's one thing you could mess up. Don't put the angle over there. Same with when you're in this quadrant. The angle goes here, right? It doesn't go out here. When you're in this quadrant, the angle goes here. It does not go on the other side. And then obviously when you're in the first quadrant, the angle goes here. So just make sure the angle is formed with the side that you plotted and the x-axis. So make sure your angle is in one of those 4 spots. All right, so from there, I like to just redraw the triangle. 24 and 7. We got to find the c. So we got 7 squared plus 24 squared equals c squared. Let's go ahead and do that. 49 plus 24 squared, 625. And so c is actually 25 again. That's good. 25. And again, my theta is there. All right, so now we can go ahead. We're asked to find the tan. Tangent is opposite over adjacent, right? That's my TOA. So the tan of theta, opposite of that would be 24. Adjacent to that would be 7. So it actually turns out we don't even need the hypotenuse for this one. I guess I could have looked at the tangent first and figured that out. But at any rate, tangent is 24 over 7. The last thing we need to consider is tangent positive or negative in this quadrant. We are in quadrant 3, right? Negative, negative. In that quadrant, tangent is positive because you would have a negative over a negative, which would make it a positive. So tangent is positive in this quadrant, which means we can go ahead and submit. All right, let's do one more here. Let's see if I can find one in the second quadrant. There we go. All right. Okay, so let's start by drawing our coordinate plane. Always just do the step first, then go ahead and plot that point. Doesn't need to be accurate, but put it out there. Negative 7, 24 is up here. Connect it to the center. And then just draw your triangle. Just go straight to the axis. So our theta goes here. Don't put the theta on the other side. You always just draw straight down to the axis or straight up to the axis from that point. All right, and then so we can label our triangle. This is in 7, and this is 24. This is 24 over here. We're always finding the hypotenuse. Okay, so if we were to redraw that, 7 and 24, we're trying to find C. So we got 7 squared plus 24 squared. I think we're going to end up getting 25 again for our C for whatever reason. I think that's what we just had, right? Was it? Yeah. 625 equals C squared. So C is 25. And our theta is here. All right, we are asked to find the secant. Secant is the opposite of cosine. So SOHCAHTOA. Secant is opposite of cosine. So secant is going to be hypotenuse over adjacent, which in this case, hypotenuse is 25. Adjacent is 7. So 25 over 7. Last consideration needs to be, is this positive or negative? It's the second quadrant, right? Quadrant 2 up here. So is secant positive or negative in that one? If you have a unit circle, you can just look at that. Secant goes along with cosine. Cosine is the x. The x is negative in this quadrant, which means the secant would be negative. So I'm going to throw a negative on the front. And boom. That is how you do it. I'll go through one more just for good time's sake here. Go through it kind of quickly. Hopefully you're starting to get the hang of it. Go at 3, negative 4. So 3 in the x, negative 4 in the y. Put our dot there. And then again, we always just draw a line straight to the axis. Boom, right there. That forms our triangle. Don't try to draw, I don't know how you would draw otherwise, but don't try to draw like a triangle this way. That would be wrong. We just draw a line straight to the axis. So that's our triangle. Theta is always the angle there. So this side is 4, because we went down, negative 4. And then this side is 3. I like to redraw my triangle. 4 and 3. Theta goes here. So if we go ahead and find our hypotenuse, our 3 squared plus 4 squared equals C squared. 9 plus 16 equals C squared. So we get 25 equals C squared, and C is 5. It's the 3, 4, 5 right triangle. We're then asked to find the cotangent. So that obviously goes with the TOA. It's the opposite of TOA. So cotangent is going to be adjacent over opposite. So adjacent of the theta would be 3, and opposite would be 4. So 3 over 4. Last consideration, we're in quadrant 4. Is cotangent positive or negative? Well, in this quadrant, the only positives are the cosine and the secant. So cotangent is negative. So this is going to be a negative 3 over 4. All right. Good luck on that, guys. Please do reach out to me if you are struggling with this. And good luck.